Okay, I'm hoping everyone can see this. Can you see, like, I'm assuming my maximized slide? Yes. Okay, cool. So I might have a hard time seeing the chat because I only am working off my laptop. So if you have like a question that needs to be answered quickly, you feel free to unmute or interrupt me at any time. I mean, I can talk a little bit more about the format about this class in a little bit, but I'll just start by introducing myself and introducing this course. If you're here, I mean, welcome everyone. I think there's like 28 or 29 people here right now. Welcome to the CAD 3D Printing Milestones course. So if you're here for CAD, you're in the right place. If you're here for 3D printing, I guess you're also in the right place. And if you're here for something else, then I guess thanks for stopping by. Anyways, well, I guess I don't know if you can see me in the corner, but this is me. My name is Andrew Pham. I'm a senior in Mechie here at Purdue. I am from San Jose, California, which is where I'm calling from today. I've been CADing for about 8 years. I love CAD. I love designing things. I'm a 3D printing enthusiast, so if you ever want to talk about 3D printing, I can talk about that a lot. Feel free to message me anytime about that. And a fun fact about me is that I'm a barista that doesn't drink coffee. Or I was a barista. I was a barista for 3 years before I came to Purdue. But yeah, it's a little bit about me. I am the only person like really running this course. I don't have any TAs currently. And just so everyone knows, there's about 100 students enrolled in this course right now. Because we're running this class asynchronously, we changed the class capacity from 80 students to infinite students. So, there's a lot of you, there's very few of me. So I'll do my best to answer any questions everyone has in a timely manner. But just know there's a lot of you. But I look forward to interacting with all of you and seeing what you all can make. But yeah. Here are just a couple things that I've made over the years. By the end of this course, you will have the technical capability. You'll technically be able to make these. Obviously, these kinds of things take a lot of time, and some of these things, you might need a little bit of experience to kind of put together. But our goal is, for the end of this course, for you to, have all the tools at your disposal to start making really cool things. Obviously, you don't have to go overboard and make something super insane like this for your final project. But we're hoping that you'll be able to do these things in the future. But yeah, so just to get everything started, we're going to start by downloading Fusion 360. Normally, you have to create an Autodesk account to get the installers, but to kind of sidestep that and make things faster, I've pre-downloaded the installers for you all, so we can get that started, and then I can kind of do more of an introduction or talk more about this course while the installers are running. So since you all are here, I'm assuming that you are in the course Discord because that's where the Zoom link is. So if you go into Discord, you can see here, if you're curious a little bit more about how I've organized this, announcements and stuff. In terms of resources, that's where we're going to kind of go for most of the in-class stuff. So today, there's a couple links here that will help you register for your Autodesk account. And then you'll also find the installer link here. In terms of course material, that's where I'm going to post all the slides and the rubrics that we use for this class, along with assignment submissions and attendance forms. I'll get to that in a little bit. This is also where I'm going to post the videos of each lecture when I upload them. General and homework help you can kind of use for general talk about this course. And then this is just here if you want to share what you're doing for the summer. I might post some fun 3D printing things or whatever that I'm doing. But yeah. Okay, back to resources. So here we're going to go to this installer link right here. It's just going to open a Google Drive folder. There's a DMG and an EXE. So if you're a Mac user, you want to download the DMG file. And then if you're a Windows user, you want to download the EXE. But you just download that and then run the file, and then it should start downloading Fusion onto your computer. But yeah, if anyone is having any issues with this, please let me know. I will say a majority of the first day is just kind of making sure everyone's squared away with Fusion, having it all downloaded. So if you've already downloaded it, you know, you're chilling for a good while, just because we want to make sure everyone's nice and set up. But yeah, I'm guessing, or I'm hoping that everyone's found this and has started downloading it. So I'll open the chat and see if anyone is having any issue. Like, please say something in the chat so I can help you out. But yeah, I'll give people maybe like a minute or two. Alright, since no one said anything, I'm assuming everything is going okay. Again, if not, please message me and I will try to help out. Or just yell at me. You can feel free to unmute yourself.
Hey Andrew, I do have a question.
Sure.
So I already had Fusion 360 already downloaded, but right now it's saying my license is expired. Is there somewhere I can like just renew the license through, or is part of the downloading like come with license as well?
Okay, that is an excellent question. So I can walk you through this now, because I'm sure some other students may encounter this. So this is relevant to those who need to renew their license or get a new license. Wait, actually, there is a slide for this. So if you want to hang tight for like 5 or 10 minutes, I'll get to that, if that sounds
All
good.
good.
Okay, cool. So to get to that, I'm just going to run through a quick class introduction first, and then I'll help out with that. Okay. Okay, so we're downloading Fusion. Just feel free to let it run in the background and, you know, at least attempt to listen to what I'm saying. But basically, you know, I guess you might be wondering why we're using Fusion 360 instead of other CAD softwares. If you didn't know, you know, Fusion 360 isn't the only CAD software out there. There's a bunch of really awesome different programs. I think you can run on VM. I can look into that. But yeah, I will get back to you on that. Local is preferred though, because VMs usually are kind of slower. Anyways, Fusion 360 is free for us students, so that's one big plus. Usually CAD softwares are very expensive, especially when you're in industry. Like, it's several thousands of dollars just for one key for one person, right? And, you know, I don't know about you, I don't really have that kind of money lying around just to CAD stuff. So it's really nice that Fusion has that or has their software for free for us students. We found that it's pretty intuitive compared to some other softwares. There's many CAD softwares that have been around for a really long time, and their UIs can be kind of annoying to work through. And Fusion, in comparison, is pretty modern, so we find it's a lot easier to use. You know, being user friendly is kind of goes hand in hand with intuitive. And then the last thing is that it's cloud based. So someone did comment about them not having a super powerful computer. One of the advantages for Fusion is that because it's cloud based, you can it does like some of the stuff, off your computer or like away from your computer. Like it stores, the models and stuff off of it. You still have some local control, but the advantage to it being cloud-based is that you can collaborate with other people, almost like Google Docs or something. So when you're working, in a group project for a design, you can kind of share a project folder, and then you can collaborate, make parts together, and that's very convenient instead of having to, email different parts and then worry about version control and stuff like that. So overall, Fusion is a pretty good choice. Again, there's a bunch of other CAD softwares out there, and they're all pretty great, but this is just kind of what we're using. In the past, I've had someone ask me if you can use a different program for this class and for the submissions and stuff. The answer is no. Please use Fusion 360 because it is a Fusion course. But yeah, a little bit more about the class. This is a milestones class, which I'm assuming that's how you signed up for this class. If you didn't know, this is one class in a series of a bunch of different classes. So we have a bunch of different skills-based workshop classes. CAD 3D printing being one of them. We have FEA and a bunch of other CAD-based classes, but we also have like programming and kind of electrical classes, like there's an Arduino class and stuff like that. So we offer a bunch of stuff. It supplements your coursework, so this is kind of an outside of class thing. It won't affect your GPA. People have asked me about that. No, it doesn't affect your GPA. But when you complete this class, you'll get a certificate through Purdue. So it's not just me getting a cert or giving you a cert, it's Purdue, the university, giving you like an official certification saying that, yes, you're qualified, you know what you're doing. So that's pretty cool. Keep in mind that the certification process is pretty long. So usually like when people pass the class in the fall semester or the spring semester, they usually wait about 3 months, maybe more. So, I will send an email to everyone who passes the class saying like, hey, congrats, you passed. So when you get that email, expect the official cert to come about 3-ish months afterwards. I promise they're coming, but once I send out everyone's names, it just kind of goes into a black hole, and I don't get any updates until they get sent. So, they will come. I know people ask me about it a lot, and I'll tell you, I haven't heard from them. But if it is an issue, I will reach out and see if I can get the status. But for the most part, it's usually just a time thing. So, yeah. If for whatever reason you need proof that you passed this class, you can have, whoever is looking at and reaching out to you asking for proof to contact me, and I guess I can verify that independently. But yeah, if you have any questions about certs, feel free to ask. Okay, so a little bit more about this course specifically. The main thing is for you to understand, why CAD is important, and then also learn all the tools to become a wow, I can't talk, a successful designer, right? So, we want to teach you all the basics, and then even teach you some more advanced skills, so you can have all these little tools in your pocket for you to make whatever you want. On top of that, we want you to be able to present your designs in a professional manner. So we're going to teach you how to render your CAD models. And then we're also going to teach you a little bit about 3D printing and how to print, how you might want to design for printing, just because that's a pretty relevant thing, at least for us students. 3D printed prototypes, they're pretty cheap. 3D printers are pretty affordable now, and it's quite popular. And hopefully this course will show you a little bit why 3D printing is pretty cool. Again, I'm kind of biased because I love 3D printing, but yeah, we're going to talk about this a little bit later though. Aside from milestones, if you didn't know, this class is being taught in collaboration with Purdue ASME. So I'm a part of this organization here at Purdue. It stands for the American Society of Mechanical Engineers. So, we collaborate with, other organizations like Milestones to bring stuff to you. So we have our own stuff, and I guess we have a couple of slides advertising what we do. But, shout out to Milestones for letting us run this course. In terms of ASME, again, we're an organization at Purdue. You don't have to be in ME to join ASME. There's a bunch of people from other majors in this, and we interact with them all the time. It's pretty lovely. The main thing is that, ASME tries to prepare the students in the organization for success in the industry. So, whether it being learning hands-on skills or, professional development with, more technical skills, or even like resume building and stuff like that. So we have a bunch of different things. I think the next slide has some stuff. There it goes. There's a bunch of different design teams. I haven't listed them all here, but we have a bunch of various groups that do different things. It's pretty cool. I was in small projects for a little while. Every semester they have like a different challenge. There's one time a few semesters ago where you were tasked with building a drone, which is pretty cool. I'm not exactly sure what they're doing this upcoming fall, but I'm excited to see what they're doing. We have like sports equipment, designing different things. Energy, Rube Goldberg. We have a prosthetics team and even a Grand Prix team. So we have a very wide variety of different design teams of, varying time commitments. So if this is something of interest to you, definitely check us out. Again, we also have professional development stuff. So, if you want help bolstering up your resume, making it look presentable, we do that too. But yeah. And then, there's a couple of different company connections we have. I think sometimes we have seminars and stuff like that. But if you're interested, there's this QR code. I think it works. If it doesn't, just let me know. I can kind of point you in the right direction to join our Slack. But yeah, that's a little bit about ASME. Okay, back to the course. This is a 5-week course, if you weren't aware. We're going to meet every day at this time, which is 8:30 to 10:30 p.m. Eastern Time. I am on the West Coast, so that's going to be like 5:30 for me. I get off work at basically 5:30, so, there's a chance I might be late, but in general, it's going to be about this time. Again, I record all the lectures. I know some people are traveling or they have very large time zone differences. So, the recordings will be there for if you miss class and stuff like that. So if you're not available, don't worry. I do encourage you to watch the videos when they come out because I do a lot of the stuff required in this class, and I'll get to that in a little bit. Again, 5 modules, because 5 weeks. We're going to start with the basics today after we get Fusion sorted out, and then we're going to go, progressively more and more advanced, right? Intermediate skills, you're going to learn about assemblies, which is pretty cool, and then we're going to be thinking about designing for manufacturing and 3D printing, and then last week, rendering, so your stuff and your final looks nice and pretty. But yeah, obviously, location is online. But yeah. Okay, so here's kind of a breakdown of all the points in this class. Again, oh wait, I can't make this go away. Okay, there it is. So 5 weeks, we have 5 different modules. They each have different point values. A lot of these assignments, again, will be done in class. So like we're gonna do everything from the basic shapes to the game piece, in the Zoom session today. Each week we'll have some kind of homework assignment or some kind of take-home thing. That's just so you can kind of work on this stuff independently. You're welcome to collaborate with friends and stuff too. But the hope is that you learn to apply these skills in a more open environment. So I'm not going to be forcing you to be like, oh, you have to do, this thing has to be this big exactly. It has to look exactly like this. We want you to kind of have the freedom to design things. Week 2 is kind of an exception because we want you to be very precise with stuff too. But for the most part, all these assignments are very open. People will ask me about dimensions and units, and for the most part, it really doesn't matter, right? If you want to design your things in miles, then you're more than welcome to. The goal is just for you to understand how the tools work, get a good understanding of how to recreate the geometries that we do in class. So don't worry if it doesn't look exactly like mine. We just want you to understand how everything works, right? To pass the class, oh, okay, this needs to be changed to Monday. But to pass the class, you just need above a 70%. So if you look at this point breakdown, 70% is definitely very achievable, especially because a large majority of these assignments are done in class, right? So if you show up to class and you follow along with what I'm doing, take your screenshots, you submit them, you're pretty set. Obviously, I'm not going to make your final for you, but for the most part, most of these points, you're pretty free. So that's why I encourage you to come to class. The main reason people don't pass this class is they, kind of forget about it or other things take priority, and people just stop turning things in. For the most part, when you turn things in, you're pretty chill. I'm not a super harsh grader, so, don't worry too much. Again, there's 100 of you, over 100 of you, and one of me, so I'm going to be grading all of these assignments. And that's quite a bit of assignments to get through. So I usually move through them pretty quickly. So I'm not going to go super harsh. But again, I encourage you to try hard in this class. I mean, every teacher would want you to do that. In terms of due dates, I need to change this slide, but it's due the following Monday before class. So if we go by Eastern time, class starts at 8:30, so all assignments from the previous week will be due at 8:29 p.m. So for week 2, all 4 of these, basic shapes, hammer, game piece, and the chair, will be due at 5:29 or 8:29 p.m. Eastern time, if that makes sense. For the final, or for the week 5 stuff, you have 1 week after that, and I'll make it midnight instead of 8:30. Or so, yeah. Just keep that in mind. Just basically 1 week to complete everything. That's usually pretty nice time frame for most of these things. So, yeah. Does anyone have any questions about like the points or the due dates, stuff like that? No? All right, sweet. Again, if you have any questions, feel free to interrupt me. Um, I would like for this to be interactive. Oh, I think someone asked something. Is there a Brightspace portal for this class? There is no Brightspace portal for this class. So everything, all the course material will be available via the course Discord, which if you're here, then you should be in already. So yeah, don't worry about the Brightspace because there is none. There isn't one. In terms of turning stuff in, if you go under course material, there's this assignment submission form. It's just a Google form. You're going to put your name and stuff like that. But the next slide will have like an upload submission. So once you finish all the assignments for the week, please submit them all at once. So, if you just did the basic shapes and the hammer and then you haven't done the game piece and chair yet, don't submit that. I would prefer if everyone submitted everything at the same time because then I have to sift through all the form submissions that are only partially complete. So I usually, for speed, I usually just grade all of them and I don't sift through them. So if you have multiple submissions, I'll grade it more than once. So I would prefer if the number of submissions was kept to a minimum. But again, if you wanted to make a change to your submission, you think you maybe missed out on some points and you wanted to get some back and you wanted to resubmit, feel free to resubmit. But just know, I will grade every submission, so if you can help it, it would be great if it was minimized. But yeah. I was gonna say one other thing. Oh, attendance. Yeah. So normally this class has mandatory attendance, but I understand everyone, is doing stuff in summer. I hope you're having fun. But I still will keep attendance forms open, and for me it's just kind of a bookkeeping thing. So if you are showing up to lecture, please fill out the attendance form. And if you're not going to be there, please fill out the absence form. The main thing for me is just I want to make sure everyone's staying engaged with the course. And, I've seen a correlation with people stopping showing up to class and, their pass rate going down. So, to keep everyone accountable, I try to have these forms here. If you're going to be missing, just let me know. Again, there's no penalty for being missing. I just prefer that you let me know, just so you're, keeping yourself accountable. You're just saying, hey, I'm not going to be there, but I'll catch up with all the stuff later, right? So that'd be great. If you can do that, please do that. So if you want, feel free to fill out the attendance form right now. Okay, any other questions? So for the first week, there would be 4 models to submit. Yes, that is correct. So we're going to model all these things. Once you're finished, you just take a screenshot of your screen, and then you put that in the submission. But yeah. Any other questions? Okay, cool. All right, so there is a final for this class, but don't be too alarmed. It's not that bad. So basically, the final is a blank canvas for you. It's basically designing and rendering your own model from scratch. I'm not going to give you any instruction on what you should make. So you can go crazy and design anything you want, preferably something school appropriate. The only main requirements is that it can't be something that we made in class. So something like the engineering fountain or the plane that we made in class is, not allowed. Just I hope that's self-explanatory. But then the other main thing is that you must have at least 5 design features. So like different extrusions or revolves, just to make sure you have some amount of complexity in there. You'll kind of notice or I hope you notice pretty early on that 5 design features is actually not that complicated. So that design requirement is pretty low, but again, it's just kind of there as a baseline. Many students go over that five design feature pretty quickly, and that is a good thing. So yeah, please have 5 design features at a minimum if you want full points. But again, most people typically have more than 5, so it's not a big deal. The last thing on here, or I guess it's not on here, but we want this or your finals to be designed for manufacturing. So typically we do 3D print the finals for this class, and I think I will continue to do that. But obviously, because this is an asynchronous course, I will either have to mail it or I will have to bring it back with me when we're all on campus. So I will print everyone's finals who want them to be printed. In terms of pickup, you'll probably have to wait till summer ends and school starts back up in the fall. But yeah, because of that, we try to encourage people to design their finals to be manufacturable, because if you want me to print something that's super super hard to print, I will still try, but it makes me sad when I give people like a pile of scrap and then they're like, "What's this?" And I'm like, "It's your final," because it was too small or something, or like something breaks when they take supports off, right? So we'll talk more about designing for manufacturing later. So I hope to give you the resources you need to design things so they won't break. But we can talk more about that later. Any other questions, or at least initial questions about the final? No. Okay, cool. All right, yeah, so this slide just a couple renderings of some of the past finals that have come out of this course. You can see here these are quite complex, so they're not exactly the just the minimum 5 design feature requirement. These are all pretty complex, like their timelines were very very long. Obviously, I don't expect everyone's to be like this, but this kind of goes to show that this kind of work is possible with the knowledge in this course. So if you do something like this, that's awesome. We might swap your project for one of these slides, or these photos on this slide here. But yeah, this isn't the expectation, but these are some that have exceeded our expectations and made us really happy. So this is possible, and I encourage you to do this, but you don't have to. I understand if you're busy. Okay, so now with all of that being said, we're going to go back into kind of preparing to make stuff in this course. By now, I hope your installer is finished running, and we can work on creating Autodesk accounts. So someone asked about getting their account renewed. I'll run through that right after this. Basically, if you're going to go into resources, there's this Autodesk registration link. If you open it up, it'll ask you, well, it's asking me to sign in, or to enter your email I've already created my account, so I can just log in. But you're going to enter your email here. It should take you to something like this, where you enter your name and some information. Sometimes they ask you for more information, and that's where you can find it here. So in some cases, Autodesk will ask you for like Purdue's address and stuff like that, or they'll ask you for Purdue's website. I've included them here if you're wondering. Purdue's address is 610 Purdue Mall. So sometimes Autodesk wants extra verification that you're a student, and that's the information that you're going to want to put in. Okay. Okay, so for those who have expired licenses or have created an Autodesk account, and it says you're on a free trial, you're gonna have to run through this like extra confirmation thing, which includes this address and stuff like that. So I've already done it, but you're gonna want to go to this link here. You're gonna select Fusion. And then you're going to say access products. It might skip it for me because I've already done it. Okay, yeah, I think it skipped it for me. But it'll ask you for like more information. Typically it's Purdue's address and and website, so just punch that in, and then it should go through. So that should apply to people with expired licenses, or if they have free trial in Fusion. Was that helpful? I forget who exactly asked, but yeah. All right. I think I can see like the wave hand thing. So if you haven't installed Fusion yet, can you like go on Zoom and raise your hand? Just so I know. If not, then we can move on and see and get everything modeled and stuff like that. Or you can just yell at me. Is everyone okay?
I'm still dealing with the license, but I think it just got approved. I'm just waiting for it to upload like the actual like the desktop app
Like, are you waiting for the app to download, or are you waiting for it to update on the, or like update your
update on the
license?
license.
Okay. Sometimes you have to like sign out on Fusion and then sign back in, and it goes away. The free trial thing won't really affect like what we're doing in class today. So, you know, if you still have that after like you run through this extra confirmation thing, then you can just run the free trial today, and if it continues to be an issue, you can just let me know.
Okay, gotcha. Thanks.
There is a way to double check that you have a seat. I'm pretty sure. Wow, this website's being slow. Okay, yeah. So if you go to, where did I go? I think I went to account. Wow, Autodesk. This is slow. Okay, yeah. So if you go under account and manage seats, you should have a Fusion seat. Because I've signed in on my laptop, it should say that I have 0 seats available, but there is a seat, right? So there's 1 seat for Fusion, which is good. If you don't have that, you might be on like a free trial or something, and we can get that fixed, or we should get that fixed. But yeah, I'm assuming everyone is like pretty much good here, so I'm gonna just start Fusion now, I think. Yep. Oh wait, there's other stuff. Okay, I'm gonna run through this first. I forgot. Alright, so now that we have Fusion installed and stuff, it's gonna ask you to create like a hub or like a group or something if it's your first time. So you feel free to name that whatever you want. I named it like Andrew's Fusion Hub for myself or something like that. It's basically just the name of the parent folder that you're gonna store everything in. So feel free to name that if you don't have, or if this is your first time with Fusion, it's going to ask you to do that. But once that's finished, we should be ready to go. I'm going to give a brief introduction to some of the stuff we're doing. I guess the first question is what is CAD? The CAD stands for Computer Aided Design. Basically, before powerful computers existed, we would have rooms of people and just on easels and paper, just drawing up parts. And that's how we did it for a very long time. But then some smart guy at MIT decided that he should use a computer to model things instead, because it allows you to quickly edit things. It's pretty awesome. Computers have gotten powerful enough that you can model more than just individual components. You can do a collections of components, which we call assemblies, and you can even simulate stuff, which is pretty awesome. But yeah, this is like one of the smart dudes at MIT. I forget his exact name, but here's just a little fun history slide. But yeah. Again, there's many applications. I just mentioned like simulation. One of those things is something called finite element analysis. So you can see here, this, you know, this part here is being simulated. There's a load being applied, presumably around here, and then you can kind of see where all the stress is going through. So it's pretty cool. You can kind of simulate parts. see if they're going to fail before you make them. So that can save you a lot of time and money in the long run. There's both 2D and 3D CAD programs. Fusion is a 3D CAD program, which is pretty sweet. And then I guess the last thing is there's like a manufacturing component. A lot of CAD programs are not just, CAD programs now, right? I mentioned simulation. In the past, that used to kind of be a separate thing. And then, manufacturing was often something else that was, or another manufacturing tool or program was needed in addition to a CAD program. So oftentimes companies will market their CAD programs as CAD packages because you can do analysis and also manufacturing in the same program. So Fusion has the ability to do all of this, but we're mainly going to be working on the three-dimensional, CAD design stuff. Someone mentioned that they may have gotten the free trial one. So again, you just want to go through this extra confirmation just to make sure you actually have, the full license. Once you do that, and you can see that you have the full license on the browser, you might have to log out and log back in to like the Fusion application on your laptop or computer. Okay. But yes, there's a bunch of different CAD softwares out there, like I mentioned earlier. There are even different CAD softwares from Autodesk themselves. Fusion 360 is one of the programs they have, but they have, other programs like Autodesk Inventor and, I don't know why I'm blanking on the other one. But they have Autodesk Inventor and a bunch of other programs. What is it? Oh yeah, AutoCAD. Yeah, I don't know why I forgot that. Autodesk isn't the only company that makes CAD programs. Dassault Systems is also a very large, big competitor to them. Their main program being SolidWorks. But there's a bunch of other programs like CATIA, Rhino, Onshape, and even like free ones. One of them is called FreeCAD, and it's surprisingly okay, but it's also pretty buggy. But again, this is a Fusion course, so we're going to be doing everything in Fusion, with the exception of 3D printing, but we'll get to that later. Alright, so with that all out of the way, I'm hoping everyone has their licensing at least somewhat in order to the point where Fusion is functional. So we're just going to start making some basic building blocks. So, Edward, I hope your thing is sorted out. Not to name drop you, but yeah. Alright, so let's launch Fusion real quick. And let's get started. Oh, great. Okay, here we go. Oh, okay, my computer's not enjoying Zoom and CAD at the same time. Okay, so once you've launched Fusion and you've created your hub or your group, I'm not sure what it's called anymore. They changed it recently. You should be in an environment that looks kind of like this. if you don't have this side panel here, that's what Fusion calls the data panel. So if you see this kind of array of squares, if you click on it, you open this data panel, and that's where you're going to store all your different Fusion files. I highly recommend you create a new project and put all the stuff that we, make in this class in that project. Some people like put it in their admin project, and sometimes it gets hard to track the files and stuff. So I recommend you create a new project. I've already done it, so mine is called Milestones CAD and 3D Printing. You can name it whatever you want. You can go into here. You can see I have many folders from past sessions. I'm just going to make a new one. But this is where we're going to store all our files. So, we're going to do the building blocks real quick, and then we're going to do that hammer, and then that game piece today. So, yeah. Just quickly, real quick, just triple checking. Please say something in the chat if Fusion isn't working for you right now, because we really want to get that sorted out at the beginning, rather than 2 weeks in and you were just sitting here for 2 hours. I'll wait 1 minute for you to say something. And if not, I'm just going to start making the blocks. Yay, it's working for someone. All right, cool. So people seem to be set. So I'm going to start. Okay, someone asked about changing the measurement settings. Default is perfectly fine. Again, for all the different assignments, the physical length of the dimensions doesn't really matter to me. As long as you're getting the geometry, somewhat correct, that's what I care about. I care about you knowing how to use the tools. So, again, if you want to make stuff in inches or if you want to make things in millimeters, they're both perfectly fine. There's one assignment where the physical and numerical dimensions really do matter, and I will specify that when that comes. But yeah, if you ever wanted to change the measurements, you can see there's this document settings tab, and you can go under units here, and then you can change it. So I personally like to CAD in millimeters, but if you ever want to change it, you can do it here. Okay. So now that everyone has Fusion working, at least I assume so, we're going to start making these building blocks. Typically, when I model things in Fusion, I make a new part or new document for every single part, but just for simplicity's sake, we're just going to do all 3 of them in the same one. So I'm going to start with a cube. I'm going to make the cylinder here, and then the bridge, and then I'm going to screenshot it. Or I'm not going to screenshot it, but you will. Okay, so just to give more space on my screen, I'm going to hide this data panel. So this work environment is a little bit larger. Again, this big blank workspace is where you're going to be a lot. This is where your model is going to appear when you start making it. I personally like to have this grid pattern. So if you want it, you can go over here and then turn it on, or if you don't want it, you can turn it off. So if you're curious, that's where it is. On the top here, you're going to find a bunch of different icons. This is where what we call the toolbar, because it houses all the different functions that you can use to manipulate a part, to create sketches, extrusions, all that fun stuff. Typically, we're going to be in the solid workspace, so you can see there's that white bar under solid, and most of these icons, have some kind of shade of blue. So we're going to want to be in this environment a lot. I've had some people accidentally move to the surface environment and everything turns orange. So if you have a bunch of orange icons, make sure you go back to solid, just because we're creating solid bodies. Down below here, we have the timeline. The timeline's blank now because we obviously haven't made anything yet. But viewing this is going to be important once we create once we start to create more advanced models. So, just a heads up, when you're taking your screenshots for this class, make sure to include the timeline in your screenshot, because I can kind of read it and it gives me an idea of what process you use to make the part. So, there's no point penalty for not submitting the timeline on week 1, but starting week 2, like if I don't see it, that is kind of important. So I can take points off for that, and it's in the rubric. So again, please make sure your timeline is visible. It's best to get to the habit of doing it now, and I'm also just telling you now. You don't want to miss out on free points just because you didn't make your screenshot big enough. But yeah. Can you point out where the timeline is again? Yes, so the timeline is just like the bottom here. You can see there's like this little play button. It's kind of cool. Once you have like a really large timeline, you can press play and it'll run you through every single operation you did. So yeah, that's the timeline. It'll become a little bit more clear once we start populating it with different things. Yeah, just the bottom. Okay, so we're going to start with this cube, nice and simple. I guess how we typically think about it when it comes to CAD softwares, it's the most common way of making something is using a 2D sketch and then manipulating it in some way to make it 3D. So for this cube, what we're going to do is we're going to draw a square, and then we're going to extrude it. So we're going to take that profile and basically pull it into the third dimension. So we need to start with a square, and to do that, we need to make a sketch. So I'm going to go up to the toolbar in the top left. I'm going to go create a sketch right here. One of the nice things about Fusion, and one of the reasons why we like to use it for teaching, is that if you hover over any of the icons, it'll kind of give you a preview of what the function or what the tool does. So you can see here, it tells you exactly what a sketch does, and it does that for a bunch of other, functions like extrude, which we're going to do in 1 minute or in a little bit. Oh, okay. One thing I forgot is kind of how you manipulate or move around in the environment. So I guess I'll go over that real quick. This is a 3D space, so it's kind of important to know how to move around in it. You can see I'm like spinning around right now. But there's multiple ways of, moving around this environment. So the first one is zooming in and out. So if you have a mouse, you just kind of scroll in and out. You can see the grid is getting bigger or smaller. The pan is just middle click. So one of the reasons why we encourage you to have a mouse for this class is so you can use the middle click function. A lot of CAD programs utilize it a lot, so it's pretty useful to have it. So the default is just middle clicking to pan side to side. So it should be like this. And then the last one is orbit. So orbit is the spinning around thing that I was doing earlier. and the default for that is shift and middle click. Personally, I changed the controls because I learned CAD on a different program and the controls are different, but you know, they all essentially do the same thing. If you don't have a mouse, I found the easiest way to orbit is by using this thing that we call the view cube in the right corner. You can see, it's a cube that kind of shows you what orientation you're in. You can also use it to snap to certain planes. Like here I can snap to the top plane just by clicking on it. It becomes nice and flat. But you can also hold down and drag it, and then it'll kind of orbit around for you. So that's pretty nice, pretty useful if you don't have a mouse and you need that in a pinch. But I do recommend a mouse because it makes things easier. Or you can use a touchscreen if you have a touchscreen laptop, which I found to be kind of nice sometimes. Anyways, back to sketching. We're going to first start by creating a sketch. You're going to get used to doing this a lot, so be very familiar with this tool. You just create a sketch. You can see these things, these planes pop up. See, if I spin around, you can see we're in a 3D space, so you need to click or select some kind of 2D plane. By default, Fusion will give you these 3 planes. You can create more, which is something we're going to be doing in future weeks, but for now, we're just going to be using these default ones. So this point here is the origin, and then they give you 3 planes, kind of going X, Y, Z, for you to make stuff on. So I'm just going to select the top plane. It doesn't really matter for this assignment, but I'm going to start with this. When you select the plane, the Fusion will kind of snap to the plane that you created, just so you can have a nice 2D workspace. So it snapped to the top plane, which I selected. You can see the toolbar changed. So before we were under solid, but now we're under sketch. So these 2 toolboxes are going to be kind of the most important ones. So again, you're going to get very familiar with this. So for the sketch tools, you can see there's a bunch of different blue and white options, along with some red options. We're mainly going to be working with these blue and white options today. These red constraint stuff is going to be more of a next week thing. But we're going to do a little bit of it today. So again, we're making a cube. So I want to have some kind of rectangle. I'm going to just select the rectangle tool. It's best practice to start your sketch from the origin, or based, at least some of your design off the origin. The origin is this one point here. You can see it's kind of gray, and it's the intersection between, this red and green line. How do you get to sketch again? There's this create sketch icon under solid. But you want to base your designs off the origin, because when you're working in a 3D space, the origin is the only defined point in space. And when you want to fully constrain things, you want to base things off of it. It'll make a little bit of sense once I start sketching stuff, so I'll just start. So I'm going to create a rectangle. I'm going to start here on the origin. You can see Fusion will kind of snap to it. I'll pull out and make it, some rectangular shape. And then you'll see here that there's 4 lines, but 2 of them are different colors. There's 2 white lines and 2 blue lines. If you're running the light theme, then I think it should be 2 black lines and 2 blue lines, but essentially they're the same thing. The main thing is that these white lines are constrained, right? Because I drew the rectangle from the origin, this point here is defined. And because of that, these two lines are also defined, because this is a vertical line and this is a horizontal line. And if it intersects with this corner, it always has to be vertical to go, or in this position to go there. These two don't really have any relation to the corner because these lengths haven't been defined yet. So these can go anywhere they want. So you can see here, if I drag this endpoint here, it moves around. So the goal for most sketches is to make them fully defined. And in doing so, you kind of create a very precise model of what you're making. So in this case, we're making a square. So, you know, these two lines should be equal to each other at some specified length. So to do that, I'm going to use the sketch dimension tool. You click on the line or the arc or whatever you want to dimension. You just move away a little bit and then you click again, and then you can specify some dimension. So in this case, I'll just do like 10 millimeters. Because we want a cube, this one should be the same. So I'm going to do the same thing here. And then boom, we have a nice, lovely square. You'll also notice that the inside of this square is kind of highlighted blue, and that's because it's a closed body, right? There's no open area. This is all enclosed. So I can make an open body real quick. I'm just going to draw a couple lines. My computer's lagging. But you can see here, I drew these 4 lines. These 2 points are pretty close to each other. They're not quite at the same point. And then the inside, you know, doesn't have any highlighted color, right? So if you ever are designing something and you want to extrude it, but you can't select it, it could be that these points are super, super close together, but they're not quite on the same spot. You'll also see that once I dimension these two lines, that these two became white, right? That means it's fully defined. You see, if I try to drag this around, it doesn't move anywhere, and it's because we applied these dimensions to lock them in place. You know, these lines here don't have any constraints really applied to them, so I can manipulate them all I want in free space, but that's not super precise. Again, the reason for why you want to go from the origin is that when you draw something away from it, like in this case, you can see all of the lines are blue instead of just 2 of them. So I hope that makes sense. So the sketch is fully constrained. If you're running the light theme, then these lines will be black, but you know, the same principle applies. You can see here, it's just a 2D square on this plane here, but we need to make it 3D. So to do that, we need to extrude it. So I'm happy with this sketch. I'm going to finish it to exit the sketch, and then I'm going to extrude it. So there's this extrude function here, right next to the create sketch. You select that, and then you specify how much you want to extrude it. You can see here there's a bunch of different parameters that you can choose from for how the tool extrudes itself. In this case, we're just going to use, you know, a basic distance specification. So I'm going to just set it to 10, and you can see it previews a cube. But there's a bunch of different options, and we're going to be exploring some of them, you know, over the next couple weeks. One of the big things is how it starts. In this case, it's starting exactly where we wanted it to, because the square sketch that we created is kind of where we want this to start. If you wanted it to be offset for some reason, you can set it to offset, or you can even set it to start at a certain object. In terms of direction, it's just one side because we're going one way, but in some cases you might want it to be extruded in two directions or symmetrically. Again, we'll explore that in later weeks. Extent type, again, just defaults to distance because we're specifying some number, but we can have it extrude up to something or even extrude through something, all the way through, the model that you've created. But yeah, you have this basic cube. I'm happy with it. I'm gonna press OK, and then bam. We have one nice, lovely cube. Does anyone have any questions? I purposely go kind of slow on the first one. Is the extrusion fixed? Is the extension fixed, like the 2D lines? Are you saying, like, is the extrusion fixed? Is that what you're asking? I'm assuming that's what you're asking. The extrusion is, like, specified. You can change the extrusion. So how you're going to do that is by going into the timeline and then editing the function or the tool that you used. So you can see here, it's a little bit more clear that it's a timeline now. You can see the first icon is the initial sketch we made, and then the second one is the extrusion. For example, if you wanted this to not be a cube and you wanted the extrusion to be longer, you can right click the extrusion, you can hit edit feature, and then you can change this distance, right? You can make it 20 instead, and then it becomes larger. Yeah. And then again, you can edit sketches as well. So this is why CAD programs are super powerful, because you can go back and change things. Again, back in the day, people did all of this on paper, and if you wanted to make a change, you'd have to like erase it or start from a new piece of paper. But for this, you can enter in the sketch, you can change dimensions, and you can finish it. And then boom, this cube is now larger. The last thing for this cube is that we want to apply some kind of appearance to it. In this case, you can see this cube is red. So to do that, we need to open the appearance library and then apply an appearance. I found the easiest way is just to use the shortcut and press A. So I'm going to press A. And then it opens the appearance library. So you can see the default is just having this nice boring gray color. But for many of the assignments, I'm going to ask you to apply an appearance. When you do apply an appearance, please don't make it like a gray or a black. Like I'd much prefer if it was a nice colorful color, just because it makes it a lot more clear when I'm grading, right? And if it looks gray to me, I might take points off. So, if you did apply an appearance that was gray and you're wondering why you lost points, that's probably why. Generally, for me, when I do these things, I use the paint appearance. So you can go under paint, I usually go under glossy, and then you can select some kind of color. Again, please don't use gray. Let's make this cube blue. So there's this nice blue color. Oftentimes you have to download the appearance before you use it. So there's this download icon. It should be pretty fast. But then it's just drag and drop. So you just take this color, drag it on, and let go. And you have a nice blue cube, or whatever color you specified. I hope that makes sense. Yeah, please don't use gray or like a black color, or else I might just take off points. How do I move the cube around? If you're talking about like moving it in space like I'm doing right now, you can see the origin is here and the cube is fixed to that origin. I'm moving around it. If you want to move it in the environment, I would just encourage you to edit the sketch to kind of manipulate it. There is this like move/copy command, but I I generally discourage this, or like not generally, I really discourage you using this because it adds like stuff in the timeline, and then you might move the thing and then make a sketch off of it, and then it makes things like really messy because your initial sketch was over here, but then because you're referencing it from over here, like this face is here, it gets kind of weird. So yes, yeah. So don't use this move copy command. I really don't like it. It's kind of a personal thing, but just note that like most other CAD programs don't have a function like this. So, you know, generally that's why I don't like using it, because I'm familiar with other CAD programs and they don't really have this. So, you know, I've just gotten used to living without it, and it's usually been okay. Any other questions about moving around? Okay, cool. So now that we have this cube finished, for those who might be experienced with CAD, you might be falling asleep because this is a pretty chill thing to do. But now that you understand this principle, I'm going to move a little bit faster for the next ones. So for the cylinder, there's two ways we could kind of go about doing this. We can do what we did with the cube. We can just draw a circle and extrude it to make it 3D. But we can also revolve it, which is what we're going to do in the game piece in a little bit. If you've taken calculus and you've done like the disc and washer stuff, this is basically an applied version of disc and washers, where you have some 2D profile, you select a plane, and then you copy it 360 degrees. So that's what I'm going to do now. If you chop a cylinder into quarters and you looked at it from one side, it's just a rectangle. So what I'm going to do is I'm going to draw a rectangle on a 2D plane, and then I'm going to revolve it. So close this. I'm going to create a sketch. I can either pick the initial planes that Fusion generates, or I can select one of the planes that we've created with our cube. So it's pretty useful. You can create features on top of features that you've created, or you can create sketches on top of features that you've created. So we're going to do that now. We're going to select this plane here. And then I'm going to be kind of bad and then create a sketch that's not based off the origin. Again, in general, it's good practice to model things off the origin, but because I'm just making a bunch of blocks in the same model, I'm just going to space them out a little bit so they don't phase through each other. In general, if I was making this for something else, I would have designed these different game pieces or blocks in like separate documents. But I'm going to leave it as is. Okay. So I drew this rectangle. One of the things you'll notice is I did this on purpose, but like you can see here, I've drawn this rectangle on this red line here, right? Fusion will even snap to the red line, but you can see all of these are blue. So you can see I can manipulate it even though I thought it was on this red line. And that's just kind of because these haven't been constrained. So that's why I recommend you going off the origin, because if you did, there's at least some points on the rectangle that's constrained, or whatever geometry you're working on, but these aren't. And sometimes they're deceptive because, again, I drew it on this line exactly, but it's not constrained to the line, so I can still manipulate it. And when you create complex sketches, sometimes you may make an assumption, and you're wondering, like, why isn't this thing like fully constrained, right? Why is this line blue? Why is it not white or black? And sometimes it's because you made some kind of assumption that this is constrained to something. In this case, like, you might assume that it's constrained to this red line, but it's actually not. And then you have to go in and add those constraints later. So that's why generally, starting from the origin is good practice, or that's one of the reasons. So I'm just going to do that. I'm going to add some dimensions. So you notice that from the last, from the cube, I just needed to have 2 dimensions to make all of these fully constrained. There's 2 dimensions here, but it's not constrained at all because I can just move it around in space. So because it's away from the origin, I need to add 2 more constraints to make it fully defined. So I added this 20 here. I'll make it bigger. I added this 20 here, this 50 there, and then, the length and the height of this rectangle. It's fully constrained. Again, it's a fully closed sketch, right? I can highlight it. It's blue inside, so that's good. I'm going to finish the sketch, and then I'm going to revolve it. So there's this revolve tool, which is right next to extrude. It'll ask you to select a profile. In this case, it automatically selected it. If it didn't, you would just go under select, click on it, and then it asks you to specify an axis, right? So an axis of rotation for this, to make it the cylinder in the way I want it to be, I'm going to select this vertical one here, and it creates that cylinder. You can select different ones. It'll result in a different geometry. This one looks good to me. You can see that you can have it do a full 360, which is what we want, or you can change it. In this case, I want 360, so I'm going to leave it. But yeah. We have this cylinder here. We're going to add an appearance. I'm going to make this one red. And then boom, we have our cylinder. Everyone good? Feel free to speak up if you want me to do something again. I don't mind. Okay. Seems like everyone's good. So, I'm going to do the last one. Oh, show the revolve. Okay. So, one of the cool things about the timeline is that you can roll things back. So you can see this vertical line here, and then the revolve there. If I drag this vertical line to be before the revolve will go away. So it'll let me do it again. There's also a folder of the sketches that I've created. In this case, the sketch for the revolve is sketch 2, so I'm going to show it again. and then I'm going to revolve it. So the revolve tool is up here under solid. We have our sketch. You need to select some kind of profile. In this case, it's, this closed area that we created with the rectangle. It'll ask you to specify an axis, so you click on that, and then you click on, some kind of a line. In this case, I selected this one, and then you've created your revolve, just like that. Can you show how to fully constrain the sketch again? Yes. These are good questions, so please don't feel bad for asking. So sketch constraining, again, is very important. We're going to be talking about it more next week. But, your goal is to make it so all of your lines are, either white or black, depending on your theme. And that basically means it won't allow you to manipulate it in some kind of free way. So you can see here, this rectangle, if I try to drag one of the corners, it doesn't let me do anything. But if I make another one over here and it's blue, I can drag it around. So to constrain it, you need to add some kind of dimension to lock it in, lock like certain parts of your sketch into space. We're going to go over geometric constraints next week, which is another way to constrain your stuff, but we're going to keep it simple and just do sketch dimensions. So, in this case, it's a 3D, not 3D, you're working on a 2D plane, so all of this needs to be constrained in at least two directions, right? So in this case, this line can move up and down, or it can move left and right, which is also just its length. So we need to constrain these things. So to make sure this line can't go up and down, we can add a vertical dimension. So I'm adding this sketch dimension here. I'm selecting this horizontal line, and then I'm referencing something that's already fixed. In this case, the origin is the only fixed point, well, ignoring this whole thing on the left, right? So I'm going to click on the origin. You can see it'll allow me to have this vertical dimension. So you have to specify it. I'll do like 10 or something. So you can see here, now it's white, right? This line is white because it can't move up and down, but it can still go side to side, which is why these are blue, these two vertical lines. So we need to change that. So we're going to go under sketch dimension 2. Yes, that's a good point. I will talk about that in a second. So I'm going to specify this dimension here. Right. You can see this is constrained. I have to set this dimension. So I can either do like the width of this, or I could do like this, right? And then I need to specify some vertical dimension to constrain this. So I could do like the height of this rectangle, or I could do the distance from the origin to the top, right? And again, the reason why I encourage you to start from the origin is that it will save you from having to do 2 extra ones, right? Because you need to specify this one and this one to get these constrained, where you could have just drawn it here and it would have been constrained automatically. So that's kind of the reason why you should start from the origin. Again, this is an edge case because we're doing multiple things in the same one. Someone asked, can't you just draw a circle sketch and extrude to make a cylinder? Is there any advantages for the revolve? So that is a good question. And you are correct, right? You could just draw a circle and extrude it. And in many cases, you will do that. I'm just kind of demonstrating the different tools. Personally, if I was making a cylinder, I would probably do what you just said, because, it's kind of faster. But it's good to know about both tools, because you can make if you're making a really round part, you can use revolves in a very like specific way to reduce the amount of features. So like for example, if I wanted like a cylinder with a hole through it, I'll do one real quick. Right, so if I wanted a cylinder with a hole through it, if I wanted to do that with just extrudes, I'd have to draw a circle and then extrude it and then draw another circle and then cut it out, right? And that's technically 2 features, but I can reduce it by doing something like this, right? So I'm leaving like a little bit of a gap between here and the origin. So let's just say, this is like 5, and then this is 10, and this is like, I don't know, 40. I'm going to leave these two unconstrained, but the principle still applies. So I have this here. Where did it go? Oh. Oh, jeez. Oh, there it is. Okay. So I have this sketch here. If I revolve it, and I revolve it, on this axis, on this vertical axis, you can see here, I just drew a rectangle, but now I have, a more complicated part, right? It's a cylinder with a hole through it, and I just drew a rectangle, right? Oh gosh, why is it doing that? So that's kind of one of the advantages to using revolves, right? Obviously, it doesn't apply to every scenario, and different people have different CAD preferences. So some people really love the revolve tool, and they'll do that for something that they can just extrude. And some people, really like the extrude tool, and they would be happy with, extruding it and then cutting out the center, right? And this either way is valid, and there's some scenarios where you might prefer one tool over the other, but at the end of the day you can achieve the same geometry with 2 different tools. So yeah. Delete this. Okay, so the last one here is making this block here. And I guess this kind of goes back to, the question you just asked, right? There's more than one way of doing this, right? We could make a rectangular prism and then cut away, the round part. Or we could also just do it all at the same time and extrude it from this face. Depending on your CAD style or, the part you're modeling, you might want to do it, in one way or the other. In this case, I'm going to just do it all in one sketch. So can you show how you revolve from the sketch? Yes. Okay, so we have the sketch here. You just want to hit revolve. It auto selects here, but if it doesn't, you just have to click profile over here, specify it, and then you pick an axis. So you hit select, and then you pick one of these lines. In this case, I chose this one, right? And then you just press OK. Again, I also am recording this session, so if you end up missing something, you can go back and watch it, or you can ask me after class. Okay, so for the last one, I'm going to do it all in one sketch. So I'm going to select, this plane here. I'm going to create a rectangle. And again, I'll do this over here. We need to add constraints. Looks fine. Okay. So I've added these constraints. Again, like I said earlier, sometimes it looks like it's in the right spot, which in this case it is, but it's not fully constrained, right? Because there technically is no constraint given. So be aware of that, because that sometimes messes up your sketches, and you're like, why isn't this constrained? Because it's where I want it to be. So sometimes you have to just drag things around to figure out what's unconstrained. One little tip I have is oftentimes I'll draw things quote unquote improperly, or in the spot that it's, or not exactly in the spot where it's going to be. And then I go back and apply the dimensions or constraints that I want, just so I can kind of visually watch it go to the spot where I want it to be, rather than it just being in the spot where I want it to be, and then I assume the constraints are applied properly. And that saved me a good amount of headache when it comes to troubleshooting why something's not constrained. So, in this case, I wanted this to be 20 above, so, making sure it's not exactly 20 away definitely helps. I'm actually going to make this wider. Okay, so we have this rectangle here, and then we want to get this kind of arch shape going. So in that case, I'm going to draw a circle on top of this. So I want this to be centered, so I'm going to hover across the line, and you can see it kind of snaps at a certain point. And when it snaps with this triangle, that's the midpoint symbol, so you know you're in the middle of this line. So it snaps there. I'm going to add some dimension, and that looks good to me, right? So you can see we have that geometry that we're looking for, but we also have a bunch of extra stuff, right? In some cases that's fine. You can just exit and extrude this. But in the case where you didn't want this, you can also trim it away with the trim tool. So if you go on the toolbar, there's this scissor icon, or the hotkey is T. You can select the tool, and then you can get rid of the stuff that you don't want. So what the trim tool does is, when you select a line or an arc, it'll trim it away to the next two, nodes, or points where it intersects something else. So in this case, this line is going horizontally through this circle. So when I hover over this bottom half, you can see it kind of highlights pink, where it's not gonna, it's pink where you're gonna cut away. So if you click it, it disappears. In this case, I don't want this horizontal line in the middle either, so I'm gonna get rid of that. You can click it, or you can also hold down, left click, and then run your mouse through where you want to cut. So I'm holding down left click, and then I move my mouse, and it goes away. In this case, you can see when I cut that line away, it made the arc unconstrained, right? And that's because the center point of the circle was based on the midpoint of that line, but we just cut the line, so that midpoint doesn't exist anymore. And now this circle is unconstrained. So we need to go back and fix this because, it can move side to side. We don't want that. We could do it in different ways. Like in one case, we can add this dimension and then do some math, right? This is 100, this is 50. And if we want both sides to be equal, this has to be 25, right? This is perfectly fine, right? It's centered, that's what we want. But, what happens if I change this to 200, right? It's not centered anymore. And in some cases, this might be exactly what you want. But in this case, it's not really what we're looking for. We want it to be centered. So a little bit of a week 2 preview. What we can do is we can set these two lines to always be equal to each other. So we're going to use some geometric constraints. There's these red icons here, and there's this equal constraint right there. So I'm going to select that tool. I'm going to click on this line, and then this line, and then bam, they're equal, right? And if I change this to back to 150, or not, wow, lag is crazy. Okay, Fusion's being weird right now. But if I change it to 150 again, then you can see all the dimensions go with it, right? So that's kind of what we're looking for. Okay, so now that we have that, we're going to do what we did before. Extrude it. And apply an appearance. All right. Does anyone have any questions about this assignment? Because if you were following along and you did all of this properly, you just got 10 points. Everything good? We're also low-key running out of time, so I'm going to kind of speed run the next couple assignments.
Yeah, Andrew, quick question.
Yeah, what's up?
So our shapes, they don't have to look exactly like they do in the rubric, right? Because in the rubric, like the shapes are kind of close to each other. But as long as you have the shapes made, it's fine however it is.
Yeah. I mean, the position of these shapes and like the overall geometry, like doesn't have to look exactly like mine, right? If your thing is like wider, or if your block is bigger, that's not a big deal. But as long
Okay, I
as
see.
as long as you have a cube, as long as you have a cylinder and like this kind of general shape, that's what we're kind of looking for.
All right, cool, thanks. And another question, what's that red lock that's next to the sketches? And sometimes there's a pencil on it as well. What do those mean?
Red lock with a pencil.
Yeah, like on the left side where you can, on the drop down of your sketches where you can select each one individually, there's like a little red lock on it.
Oh, this one?
Yeah, that.
I think the red lock means it's fully constrained. I've actually never really noticed that. Let me
Ah,
test
okay.
that theory real quick. So, yeah, so I think you see like it's red locked because like everything is fully constrained. The
Mm-hmm.
sketch I just made is like, it has no constraint applied to it. Unless it means
I
it has
see.
some feature tied to it. Let me see
I
if I
see.
actually. Yeah, so
Okay.
even when if I add an extrusion, it's still like a pencil, which means it's not fully constrained. Okay, that's
All right.
actually a good thing to know because I actually didn't really notice that.
Yeah,
Thank you.
cool, thanks.
Yeah. Okay, so for me it's 7:20, which means we technically have 10 minutes. So we might have to go over today. But I'm gonna try to make it quick for everyone. I usually run through the first assignment pretty slowly, just so everyone has a very solid foundation, because you can use these concepts to apply it to assignments 2 and 3. So I'm gonna go a little bit faster now. Okay. So this looks good to me. I'm gonna save it. And then I'm gonna make a new file. So I'm gonna do Control N or Command N if you're using Mac. And now I'm gonna start on this hammer. So if we look at the hammer, there's a couple things going on here. There's this, cylinder looking thing with another cylinder on top, and then there's this rectangular prism with some like curved edges. So again, there's more than one way of doing this. Personally, I like to start with the handle, so I'm going to make some kind of cylinder, but I'm going to kind of combine both the top and the bottom cylinder as one thing. So what I'm going to do is I'm going to make one cylinder and then make a rectangular prism at an offset from the top. So that it might make a little bit more sense once I start doing it. It's perfectly valid if you make, one cylinder, a rectangular prism, and another cylinder on top. But I think what I'm going to do is a little bit more efficient. So I'm going to start a sketch here. I'm going to click on the top. I'm going to create a circle. And then, again, it's based off the origin. I'm going to add some dimension here. Finish this. And then I'm going to extrude it. I'm going to make this extrusion like kind of extra long, like 300. Yeah, that looks good. So I have this cylinder here, but now I want to make kind of like that hammer head. So what I'm going to do is I'm going to draw a rectangle that's centered on this circle, right? So create a sketch. I'm going to select the top face of the cylinder, and then I'm going to draw my rectangle. So this is a good like scenario to show like why you want to base things off the origin, because this circle is centered on the origin, and then I also want this rectangle to be centered on the origin. So if I had the circle at an offset, then I'd also have to apply the offset to the rectangle, which means more dimensions, and that also means if that offset was to change on the circle, then you have to go back and also edit the rectangle. So to avoid that, I just base things off the origin. In this case, I want a centered rectangle, so I'm going to go under the Create menu and go under Rectangle and Centered Rectangle. You can see there's a bunch more, or a bunch of extra, sketch tools if you're curious. But I'm going to make a centered rectangle here. I'm going to specify some dimensions. So that looks good to me. Again, centered on the origin. I only need two things. Nice and quick, nice and easy. I'm going to finish this sketch. And then I'm going to get ready to extrude it now. So you can see here, I made the sketch on this top face, but we also want a little bit of it exposed. So I'm going to create an extrusion. I'm going to select this profile. And then instead of starting on the profile plane, which is where I sketched it, I'm going to have it set as offset instead. Someone asked, can you show that centered rectangle method again? When you're under the sketch, you want to go under create, like this create tab. There's a rectangle option, and then there's a centered rectangle option. And then wherever you start dragging from is going to be the center of your rectangle. So, I put my mouse on the origin and then I drag it out. If that makes sense. Okay, okay, cool. So again, instead of starting from the profile plane where I created this sketch, I'm going to create an offset instead. You can see this arrow direction is where the offset direction, so I want it to go down. So in this case, the arrow is pointing up, so I'm going to set the offset to be a negative number, like negative 10. And then I'm going to specify the extrusion distance. So in this case, again, the arrow is going up, so I want the extrusion distance to be negative. And then there we go. So you can see here, this blue area is where the sketch was created, but then there's this offset of, in my case, 10 millimeters. So there's a 10 millimeter gap before the extrusion starts and extrudes downwards 50 millimeters, right? So that's one of the ways you can use the offset from the sketch, or for the extrusion. Yeah, so now I have a hammer. You can see in the timeline there's only two major features here, right? So these two blue icons are the two different extrusions I made. So it's a little bit more compact, a little bit more efficient, and I like that. The last thing for the hammer is adding some fillets or rounded edges. So there's this tool here called the fillet tool. And then when you enter it, you just start selecting edges or faces that you want with rounded corners. So what I normally do, or what I'm going to do here, is I'm going to select these two faces here. So I select that, spin around, and then I'm going to select these edges, just like that. And then once you have those things selected, you specify some radius, and then it rounds them nicely. One thing to note, this is something that's kind of unique to Fusion, at least compared to the other programs I've tried. You can kind of nest different features. Like in this case, I can like nest more than one fillet in the same tool. So I'm going to redo this 1 second. So for a lot of programs, if you want one part to have a certain fillet radius and another one to have another radius, you'd have to create two different fillet tools and do them separately. But you can kind of combine them in Fusion, which I find kind of cool. So, let's say we want these faces to have small fillets, and then these edges to have larger fillets. So I can select these two faces and just do like a 5 millimeter fillet. And then I can add more fillets by adding a selection set here, and then selecting these separately. So I can set this to like 10, like it was before. And now you can see these radii are larger than these. But once I finish this, they're all housed in the same function, which I think is really nice. That's just kind of a side tangent thing. But yeah, if you did everything, if you were following along, you should have this game piece, or not game piece, this hammer right here. It is technically past class time, so if you need to go, then feel free to leave. But I'm going to try to crank out this game piece real quick. Any questions on this before I move on? Cool. What assignments are due next week? So if you look at the rubric, the week 1 rubric has everything that's due next week. So it's this, the game piece, which I'm about to do, and the homework assignment, which is creating a chair. So if you go under the slides, that's what we're looking for. So all 4 of those things are due. But I'm just going to run through the game piece real quick. Okay, so for the game piece, we're going to be using the revolve tool, very similar to what we did with the cylinder. So we're going to make this more complex shape, revolve it, and then we're going to add text at the bottom. So made a new document, creating a sketch. In this case, I typically don't pick the top plane. I usually pick left or right, and then I just start sketching. So one of the things I like to do is I just like throwing down a bunch of lines and arcs and then constraining them afterwards. So some people like to do like one thing at a time, but I like a little bit of chaos. So I have these 3 lines here. I know there's going to be like a circle up there, some line going this way, and then there's going to be an arc that connects these 2 points. So I'm going to go under create an arc. In this case, I'm going to use a 3-point arc. There. And then there. Okay, so we have this very like corrupted looking profile of this game piece, but now we can start to refine it. So I'm going to use a couple of geometric constraints, which is kind of a week 2 thing, but this is kind of a sneak preview. So I want this line to be horizontal and this line to be vertical. So I'm going to use the horizontal vertical constraint to snap these in the right spot. They turned white, which is good. And then for this, there needs to be a smooth transition between this diagonal line and this arc. So I'm going to use the tangent constraint here. Selecting the line and the arc. Now it's nice and smooth. So that looks good to me. I'm going to start adding dimensional constraints. So, maybe this will be 25. I guess it's 15 now. 50. And then for this line here, you can use the dimension constraint to set an angle. So I'm going to click on this vertical line and this this diagonal. And you can see I can specify an angle. So I'm going to do like 20 degrees. I need to specify this radius. And then I think I need one more. Like that. So this is fully constrained. It's almost done. you can see here there's a bunch of kind of separate parts. So I'm going to need to add a little bit more. I'm going to add one vertical line going here. And then I'm going to trim away the excess. So trim, I'm going to cut this line here, or this arc. And then I'm going to cut this away, there. If I didn't have this vertical line here, right, if I tried to trim away, it would trim this whole piece away, which is not what we're looking for. So all right, so that looks good. I'm going to trim this and that. And now we have a completed profile. So I'm going to finish that, and I'm going to revolve it just like I did for the cylinder, right? Oh, geez. I'm going to select the profile, and then the axis. In this case, it's this vertical line here. And we have a nice game piece. We need to add text at the bottom. So I'm going to create a sketch selecting the bottom face. And then I'm going to go under Create Text. I'm going to, make a text box here. I'm going to write some stuff. Make sure you leave the little apostrophes on both ends, because if you don't have it, I think the text doesn't work. So yeah, make sure it's there. Select OK. Finish the sketch, and then we're going to extrude it. So Fusion will default in some cases to select things that you don't want. In this case, it selected the whole bottom. Wow, I'm hiccuping. It selects the whole bottom face, which is not what we want. We just want the text, so I'm going to delete the selection, and then I'm going to zoom in, click on the text that we want. And then I want it to go into the game piece. So this arrow is going, out of the game piece, so I want it to go the opposite direction. So I'm going to go like -2. You can see the operation changes from join to cut, which is good. And then I select OK. And now we have some nice text on the bottom of our game piece. The last thing to do here is apply an appearance. So it's the same process as before. I'll make a blue game piece today. Just drag and drop after you open the library by pressing A. But yeah, that's about it for this assignment. And if you're following along, you can just take screenshots and submit that after you finish the homework assignment. Does anyone have any questions about this game piece? I know I went a lot faster compared to the other things, other assignments. The text, you need to make a sketch. So you create a sketch on the bottom, and then it's create text. So sketch, create text right here. Yeah. How to do the arc again. I'm assuming you're talking about this diagonal one here. So So for this diagonal here in the arc, is create. For the arc, it's create arc and then 3-point arc. And then you just select the ends of this line and that line. So do we need to submit this Fusion file? No, you don't. I just need a screenshot. Okay, so we have like this, right? To make the smooth transition, you use the tangent constraint here, and then you just click on the line in the arc. And it makes it nice and smooth. Is that what you're asking? Cool. All right. Any other questions? If not, then I'll move on to explaining the homework, because I know we're over time today. I'm also
I
gonna
had a
get,
quick question.
yeah, sure.
So earlier I thought like for the shapes those would be like submitted separately. So do you want me to like just take a screenshot of each like shape, or do you want me to just add them all to the same file?
I mean, if you want to submit 3 different screenshots and just put them in, that's totally fine too.
Okay.
I just did them in one, just because, you know, it just makes one screenshot. But if you submit 3 screenshots, it's not a big deal.
Okay.
Yeah. Okay. For the homework, you know, you're just applying what you learned today to create a chair. So, you know, hopefully now when you look at this, you can start to visualize what kind of steps someone took to make this, right? You know, these legs could be extrusions. You can see there's some rounded corners, so that might mean some fillets and stuff like that. But again, these requirements are pretty loose, so you can kind of create whatever kind of chair you want. You know, as long as it has like 4 legs and stuff and like a place to sit. So, you know, if you want to use revolves, you can. You know, you can make round legs instead of more square ones. But yeah, these homework assignments are pretty open. So we encourage your creativity. I've seen a lot of really nice chairs. I've seen a lot of cursed chairs that look really funny. So feel free to go ham on this. It's just, you know, kind of here for you to take inspiration. But you can make whatever you want. But other than that, we're basically done for today. I'm going to get kicked out of my office soon because I need to leave at 8. So if anyone has any quick questions, I'm happy to answer them. If not, I'm going to wrap up and then get out of here.
Thanks, Andrew. Have a good night.
No problem, you too.
I had a question about the Fusion because for some reason I'm still on the 30-day free trial one and I don't know how to get off it.
Okay. 1 second. I'm going to stop the recording then.